Dear friends, hearty welcome to the online problem solving session on linear algebra and real analysis organized by Maths Aspirants. As you know, Maths Aspirants is a community of math lovers, students, research scholars, and faculty members across India, initiated by myself in 2017. And we used to arrange several online programs to help the students who are pursuing higher mathematics. We used to organize online test series, online problem solving session series, and national webinars. Today, we have an online problem solving session series, especially focusing on the CSIR NET examination. Today, we're blessed to have Ms. Sneha, a senior research scholar, senior research fellow from Indian Statistical Institute, Bangalore. Ms. Sneha qualified in BHM examination, CSIR NET with JRF and GATE examination. And also she secured first rank during her BSc and MSc. I'm sure that we have got a right person to discuss the problems from this particular area. And her broad research area is functional analysis. So I'm sure that she will help you to get to make all efforts for your final round preparations. I welcome everyone to this program, and I would like to express my sincere gratitude to Ms. Sneha for being with Math Aspirants. Once again, I welcome everyone. Welcome, Sneha.
Thank you, sir, and thank you for a nice introduction. Also, I would like to thank you, Maths Aspirant Group, for giving me such an opportunity. So, shall we start now?
Yes.
So, before starting, I want to tell you two things. One is that the class is not one-sided class. I won't be just doing problems. You should not just take it out and work out later. The thing will be, I will be sharing only questions. You are going to solve the things and give me some ideas to solve. So I will share the board and we will solve online, not like later you solve the things, or you may skip some in between things what I say, and then you go for your own work and then do that. That will be too hectic for you. So whenever you feel you are missing some point in between, then you can pause me and ask. Also, since I am sharing the page, I cannot see the messages that you are sharing. So you are free to switch on your audio and then ask me any question at any time. And whenever I ask to think, you all should think, do the work, and then once you are finished, you can tell me that I am done. And after some time, we will discuss the answer. So I will be mixing between linear algebra and real analysis. So the first question comes from linear algebra. Given an alpha in R, you have a matrix corresponding to it. What is that matrix? A alpha is a 3 by 3 matrix. 2 minus 1 0, minus 1 2 minus 1, 0 minus 1 alpha. Now WOFT always means which of the following is true. So you may think upon it. A alpha is positive definite under which condition? That is the question mainly. So how you proceed and how you do the things, you may take a minute and then let's discuss. So as soon as you see the word positive definite, something should strike in your mind given a matrix. What is that strikes your mind at very first moment?
Every eigenvalues must be positive.
Yes. Then another some ideas.
Determinant all the minors should be positive.
Exactly. So the easiest way will be to find the minors. and then check whether they are positive. Of course, the eigenvalues positives is true, but from here, the easiest way will be doing that, right? Because if there is no need of finding the characteristic polynomial, then solve it. It is a 3 by 3. So it may take more than 2 minutes, which is not so good if you go for an exam. Okay. So better you do in this way. Minor, then main, another minor, and then the final minor. This should be positive. Determinant of these minors. So do it and then tell me.
Option B.
Okay. Hope everyone have done this, right? Okay, this is a simple problem. So, add input. So this is a very simple problem. So let's do a few steps on it. As I was telling, the minus should be positive. There is no need to check the determinant of this because it is what they have given. So instead of wasting time on it, we can just check the determinant of A alpha is positive or not, or when determinant of A alpha is positive. So when is it positive? It will be better to expand in the first, right? So it is 2 times 2 alpha minus 1 plus 1 into minus alpha. This should be positive. Or in other words, this is 4 minus 1, 3 alpha minus 2 should be positive. That is, alpha should be greater than 2 by 3. Now we know for every such alpha, this A alpha is positive. Now come into the options. What are they saying? For every alpha less than 3, of course, alpha less than 3 doesn't coincide with this part. So that is wrong. Now, alpha greater than 3 means, yes, alpha greater than 3 is always greater than 2 by 3. So that is an option. And if it is a B part, stop here. Don't go to C and D when you are doing an exam. When you do practice, then you can check each and every option. So that will be also a good, very good point to do in the examination. Don't check one by one everything and then see if it is a section B question. Okay, shall I go? Next question. I couldn't hear.
Yes, sir.
Sorry, I couldn't hear.
Yes, ma'am.
Oh, you were saying yes. Okay. Now, this is a very basic question. In some way or the other way, this kind of question always occur in a NET exam. So something related to countability and countability will be always there in a NET paper. So whichever question I do today is only the questions that occur in 2023 June or December section. So you can see, let X be a finite set. Then what they are considering? Y to be a new set defined out of X. What is this Y? Consider any function from X to R. Consider its pre-image at 0. Then which of the following is true? Then they are claiming that Y is of cardinality infinity. Y has 2 power cardinality X elements. There exists a bijection from X to Y and there exists a surjection from X to Y. So this also is a very simple question. You may think upon it for a minute and then let me know. If you don't understand any meaning, then you can ask me now.
மூலமா எஸ்கேப் ஆயிட்டு திரும்ப
What? Sorry, are you really talking to me? Or okay, have anyone done with this?
Answer B.
Yes. I guess almost everyone will have got B. So the basic thing is this. What is this Y actually? It is nothing but
Set of all
consider.
subsets.
Yes. What can a pre-image of 0 be? So it can be any subset of X, right? So what actually Y is saying? Set of all subsets of X. What is it actually? The power set of X. Right. Now consider it this. If X is finite, then power set has cardinality 2 power cardinality X. So of course this is the answer. So infinity is wrong. And addressing this question, why I am considering this here is that you have to know a very good theorem, which is called Cantor's theorem. What does he say? You may take any set X. P of X does not have same cardinality of X. This is a basic result that we learn in real analysis, I guess in 6th semester itself. So this, if we know, then it will be very good to deal with countability, uncountability, everything, even if we are given infinite sets like this. Infinite set is given. Now they are asking whether this is true or not. There exists a bijection or not. If this is a question, then within a second or by just calculating something, we cannot say that there is no bijection because this is countable. This is something we don't know. But this theorem always helps us to say that for any set P of X and that set have no bijection. Shall we move on to next? Okay.
Yes, ma'am.
Ma'am,
Okay.
I have a doubt in
Uh-huh,
that question. If F is continuous, like that some condition is given, then can we say anything about the cardinality?
Okay.
Then if
So
the
X is
inverse
an
image of
arbitrary set, right?
yes, ma'am.
So if you are defining a continuous notion on it, you have to first give a norm or distance notion on X, right?
Yes, ma'am.
So what distance you plan to give on X? Euclidean distance you want?
Yes, Euclidean, our usual metric distance.
Okay, then let's consider X subset of R with usual distance or the Euclidean distance, whatever you call it. Okay.
Yes, ma'am.
Then, since this X is finite, it will lie somewhere like this, right? 1, 2, 3, 4. Say 1, 2, 3, 4. This is our x. Okay.
Yes, ma'am.
Now, if you are describing a function on a finite set, it is automatically continuous. Why?
Yes, because it is
Because
isolated point.
because you can choose a very small interval which contain only 1 in the set, right?
Yes, ma'am.
So in fact, any set of all continuous function is equivalent to any function on X. So the question lands up same, right?
Yes, ma'am.
Is it uniform continuous?
Of course, uniform continuous. It has only 4 values to take.
Okay.
Right. Okay.
Okay, ma'am.
Now the next question is, if A is a 3 by 2 real valued matrix and B is a 2 by 3 real valued matrix such that BA is identity of order 2, means 2 by 2 matrix identity, then AB is also identity and of 3 by 3 order. And second is, if A is a given matrix, the field is over R, then there exists Z valued 2 by 2 matrix such that AB is I2. And the next is, given this matrix in Z6, Z6 you might be familiar with, right? Modulo 6. Then there will be a B such that again over Z6, AB is identity. And if A is a real non-zero 3 by 3 diagonal matrix, then there exists a real matrix such that AB is identity. Now, this is also easy, but not so trivial. So you can take 2-3 minutes on it and then tell me. And meanwhile, if you have any doubts in the notations or the way which I have written, you can ask me.
In option C,
Hmm.
the field is Z6. I
Yes.
think Z6 is not a field, right?
We don't need any field nature over here. We are
Okay.
just saying elements comes from Z6.
Okay, then the operations of this field, I mean, what are the
Z6 is a ring, right?
sorry?
Z6 is always a ring with dot and plus, modulo 6, right?
Oh, okay, fine. Oh, okay.
So you
We
can
have to
always
take that.
do matrix multiplication.
Okay.
Everything exists.
Okay.
It doesn't talks about invertibility actually. It just talks about there exists a B such that AB is identity.
B and C will be the right answers.
Which all?
B and C.
Can you repeat? B and C. How you got B? Check it 1 second. You need
Is
that.
it multi-correct?
Oh, that we don't need to think. Like it may be from B, it may be from C. Even though if it is in C, it can be just having a single answer.
I think the answers are C and D.
Oh,
Only
C and
C.
D? Why D? Only C.
Only C.
Hmm. Since others might be still doing, I will wait for a minute and then I will explain.
Wait, non-zero diagonal matrix means all, like any entry
No,
is
I
non-zero.
have not said non-zero diagonal. It just says A is a real non-zero 3x3 diagonal matrix. Diagonal is non-zero is not given.
Oh, I see. I got confused. I see. Okay, then only
that's
C
all.
is correct.
That's all. Okay, then shall we discuss?
Yes,
Yes, ma'am.
Okay. So for the first thing, you need first a 3x2 matrix. So how does it look like? Let's take the very easier thing. This is a 3x2 matrix. And let's take another easier thing. This is A. And for my convenience, okay, no problem. This is B. So it will be a 2x3 matrix, right? 1 0 0 0 1 0. Now check what is BA. BA is nothing but 1 0 0 0 1 0 1 0 0 1 0 0. So this says consider its first column. That is nothing but 1 0. This says consider its second column. That is nothing but 0 1. So this is I2. But now if you consider AB, what does this say? Consider its first column. That is 1 0 0. Consider its second column. That is 0 1 0. Consider 0 times anything. Like that will be 0 0 0. Now see. We got counter example, right? We had A, B, such that BA is I2, but then AB is not I3. You may have plenty of reasons to negate these parts. You may do in any way as you wish. Okay. Now, what does this say? Suppose we have a B such that this happens. That is 3, 3, 1, 2. And let me write it to be X, Y, Z, W. This is my B. This is to be identity. Then what does it say? 3x plus 3z should be 1. Or 3 into x plus z should be 1. Means what? This 3 should divide 1, right? That is the meaning what we write like this. If x and z come from integers, then x plus z also come from integer. Then this just means that 3 divides 1, which is a contradiction, not possible, right? So right from here, we can say that this is not true. So the one who answered me B and C, are you clear now?
Yes, ma'am.
Okay. Now, it is easy to avoid D. So let's do that. So A is a 3x3 real non-zero matrix, which is diagonal. Means you can just take 1 0 0 0, 0, 0, 0, 0. So this is actually a matrix satisfying every condition. But then we know that this is not invertible, right? Because anything that comes over here, if you take the second, then it lands up into 0, 0, 0. So if you take this row and multiply this, then it lands up into 0, 0, 0. Means what? This is not invertible. So this is also false. Now we have to check 3, 1, 1, 2. If you are in an exam hall, no need to check. You can just tick and come. Don't waste your time. But since we are practicing now, we have to check. What is A? 3, 1, 1, 2. Now you have to find B on right or left. Right. So let B be again X, Y, Z, W. This we want it to be 1, 0, 0. Now what does it say? 3x plus z should be 1. 3y plus w should be 0. All these 1 and 0 are in Z6. Okay. It doesn't mean an element, it means an equivalence class. X plus 2z equal to 0. Y plus 2w is 1. Now, where are the same things here? So you may multiply by this 3 and then subtract. So what will be the thing? Okay, minus w will be 3, right? So this is, should I write each and every step or is it okay for you?
It is okay.
Okay. Then it says nothing like this. Then w is actually 3. Now with w equal to 3, you may put y equal to 1. But the thing is that you have to check whether y equal to 1 and w equal to 3 satisfies this condition also. This is an important point that you have to note, because you may choose w equal to 3 here, right? Then you can also choose something else over here. You may choose y equal to 3. Not 3. Minus 1. You can choose minus 1 over here, which is actually 5. Then you have to check whether 5 plus 2 times 3 equals 1 or not. That is not true. So I am saying whenever you solve an equation and get a value, you will surely substitute that value in one of the equation and see the other value. But don't forget in any case to substitute it in the second equation and verify, because that may lead to some issues. So now we got this. Now from here, is there any message?
There's a mistake in calculation.
Oh, maybe. What is the mistake?
5W equal to 3.
What?
How is possible, madam? Minus W equal to 3.
No,
When
that's
solving
minus.
second and fourth equation, we get 3 into 2W, 6W minus W. We get 5W equal to 3, madam.
5 means minus 1 modulo 6. So in Z6, 0 corresponds to all multiples of 6. 1 corresponds to all multiple of 6 plus 1. 2 corresponds to all multiples of 6 plus 2. And if you see 5, then it corresponds to all multiple of 6 plus 5, right?
Yes,
Now, can I write this as minus 1? You just put m equal to minus 1. So in set 6, actually -1 and 5 are same. Okay. Is this what you were asking?
Yes, ma'am. But when we solve,
Hmm.
we are multiplying the fourth equation by 3. So 3y plus 6w equal to 5. Sorry, 3. When we
But then
subtract
what is 6w?
6w
6w is actually 0, right?
Ma'am, in the second equation we have w. We have to subtract both the things, so we can get minus 5w.
I agreed. Oh, minus 5w. No, 5w. So,
Okay, ma'am.
for your
5w.
convenience, I will
Okay,
write
5w equal to 3. 5w equal to
3.
Let me write. So this is
Yes.
nothing but 6w equal to 3, right? This is okay?
Yes, ma'am.
Yes,
So
ma'am.
what is 6w? It is nothing but 0 for every w, right? Because it's a multiple of 6.
Okay, ma'am. Okay, ma'am.
That's why I was doing. For easy convenience, I was reducing the numbers. You can do anyway, no problem. Good that you pointed out. Okay. So this is the case. And if you do this and this, then it's clubbing. Like I will multiply 3 here and then again subtract. So it will be 3x plus 6z, which I again replace by 0, equal to 0. And the first one is 3x plus z equal to 1. Now if you subtract, then it is z equal to 1. Now z equal to 1 forces you to give 3x equal to 0 here. And if you see z equal to 1, then you have x plus 2 is also 0. See? So if from here you are choosing x equal to 0, then your x is not satisfying here. That's why I was reminding you later that you have to consider both the equations. But if you choose this x to be 4, then 3 into 4, 12, modulo 6 is 0, and 4 plus 2 is 0. So the best answer is that the inverse is 4, 1, and where is my z? 1, and w, 3. Is this okay for you?
Why are we doing this way? We can just find the adjoint matrix, right?
Yeah. Because it's 2 by 2, you know the adjoint matrix will work. Right?
Oh, okay.
But still, there might be some issues in your exam hall that we are in Z6, not in R. So that
But
point
the
makes.
adjoint works in any commutative ring, right?
Yes, but there is a notion of field coming over there still, right? We are taking the inverse, right? We are taking the determinant and saying 1 by determinant.
I mean,
Yes,
yeah, but
ma'am.
as long as the determinant is non-zero, it shouldn't be an issue.
No,
Are
the
you
determinant of
saying it's possible in
something.
any ZP? Like in a prime base, it's possible, but in Z6, it's not prime, so probably not possible.
That is the point. So determinant may be
Yes.
3. This is non-zero. How can you invert it?
I mean, in that case, I don't think the matrix will be invertible.
That is a point. But then I was just making you sure that that matrix exists.
I see. Okay. I see.
Now again, analysis part. So you are given with two series. One is sine n pi by 2 by square root n, and another is log of 1 plus 1 by n square. Again, the question deals about the convergence of the series. So better check the convergence of A and B, then choose the answer. Now you can take 2 minutes. Hmm? Okay, any idea?
C will be the right.
Please repeat. Hello. Can you please repeat? I couldn't hear you properly.
C will be the right. Both A and B will be convergent.
A, B will be convergent. Okay. So it's an easy task, right? If you don't know some test or something, then you are done. So what is the sign of n pi by 2? How does sign looks like? This is pi by 2. So 2 pi by 2 will be here. 3 pi by 2 will be here. 4 pi by 2 will be here, like that. So from here, what does we say? What is the observation? So for even terms, it is 0. Right? And for the odd terms, it again oscillates between 1 and -1. So how does we write this? This is -1 power k, where this n is actually for k plus 1. And okay, instead of writing like this, we can again split it like it is 0 if n equal to 2k. And it will be if n equal to 2k plus 1, then again we can split k into odd or even. So I will write 2r or 2r plus 1. This will be r. Why I am making it like this is, there is no need of such things. We just want to know This is an alternating series. Right? This is what is remaining. Some variation. So this is an alternating series. So as soon as we see something alternating, which test should come to our mind? Alternating series test. What does it says? If we have something like this, limit may be anything. So this Bn should be positive. That's why we are taking out the negative part here, and Bn should be positive. 0 is also allowed, positive. If this Bn decreases to 0, this is a notation of decreasing to 0, means Bn plus 1 should be less than or equal to Bn, and this limit Bn should converge to 0. Then series converges. This is a very good result because we actually don't know how to deal with this plus or minus, right? Almost all tests like limit comparison, direct comparison, everything fails when it comes to plus or minus. So alternating series will help us. So in this manner, we can easily see that Bn is nothing but 1 by root n, which is positive, and it is decreasing to 0. So by alternating series test, this converges. So A convergent is known. Now you see, what is this logarithm? The log graph is like this. It touches the x-axis at 1 and it approaches the minus infinity near 0, right? So this is the graph. So since our term starts from 1 onwards, like 1 plus something, we are always in their positive part. So that we can use comparison test, limit comparison test, anything that we want. So now we have log of 1 plus 1 by n square. This is actually a. Now I would like to compare it with 1 by n square, which I know is convergent. Then what is limit an by bn? Sm tends to infinity. This is nothing but limit log of 1 plus 1 by n square by 1 by n square. Now if you see this, this is actually log of 1, which is 0. Again, this is 1 by infinity, 0. So this has 0 by 0 form. So whenever something comes like this, what rule we apply? Whatever you pronounce, I pronounce it as L'Hopital's rule. What does it say? This limit is same as the limit when taken with the separate derivatives, right? So what is the derivative of this? 1 by 1 plus 1 by n square into minus 2 by n cube and the whole by minus 2 by n cube. So this and this gets cancelled, and this is nothing but limit is 1, right? So what we have, if the limit of this ratio is actually positive, then both converges or both diverges. The things happens together. And since we know this is convergent, summation an is also convergent. Is it okay?
Ma'am, in
We
last
have
step, log is
tell me.
limit n tends to infinity of 1 plus 1 by n squared only convergent, madam. But given that log of 1 plus 1 by n squared, madam.
Sorry, the thing is, L'Hopital's rule says limit fx by gx. If this has 0 by 0 form, then it is nothing but limit f dash x by g dash.
I know that, madam, L'Hopital rule. But in last
So what
step,
is the derivative of log of 1 plus 1 by n square?
Is it true for
madam, but last step only I asked this, madam. Finally, we get limit n tends to infinity 1 by 1 plus 1 by n squared.
Yes.
But given question is log of 1 plus 1 by n squared. How to relate the resultant?
So why do you want to relate it? That is my question. The thing is, the limit test just says if you take an to be the given term and bn to be the known term, and if you have an to bn some positive limit, then both the series behave similarly, right? So in order to evaluate this limit, we are just using L'Hopital's rule. And L'Hopital's rule boils down this log part to 1 by 1 plus 1 by n square. And now here there is no log.
Ma'am, it's a limit comparison test, na? Yeah, okay, ma'am.
Is it
we can also
tell me, we can also?
we can also directly use that log 1 plus x is bounded by x, right?
Log 1 plus x is bounded by x. Is that clear? Yes, that proof comes via this only, right?
I mean, I remember it from my CS class where log is small o of x, strictly less
The
than.
thing is, log x is like this, and you have x like this, right? So I agree to your point that log x is always less than or equal to x. This I agree. But how do I immediately see, if I don't know, how do I immediately see this?
I mean, 1 plus x will just shift the graph slightly.
How slightly? How much? Like it will shift to 1.
I mean, even if there is a bit, it goes slightly for large values of n, it will remain below.
I agree. The thing is, after some stage, it will land up like this. That is true. But that is a very vague idea of thinking, right? You are correct.
L'Hopital rule only applicable for x tends to finite value, right? So here is x is infinite.
No. L'Hopital's rule is applicable everywhere. You can just change the function to be 1 by n tends to 0 and consider the same.
Okay.
So that is okay. You can use x tends to infinity also. The guy who was asking me with this log and 1 by 1 plus 1 by n square, are you clear now?
I mean, like my thinking was like log 1 plus 1 by n square will be bounded by 1 by n square, and then we take summation both sides. We know summation 1 by n square is like pi square by 6. So it's
Of course, that
convergent.
is direct comparison test. You can do once you are sure log of 1 plus 1, 1 by n square is bounded above by 1 by n square. Okay.
See.
I guess the one who were asking is still having some doubt. Maybe you can ask me later, or you can message me. Let's move on to next question. Now, this is a very good thing to check. Which of the following is false? Whenever you are in exam hall, you just read which of the following is true, and then you know the answer, then you put the answers ulta. Like that makes us feel very bad when we reach home. So it is better to go through step by step what question is asking, like false or true, then make sure it is false or true, then proceed to answer. In B part, anyway you will get, because more than one option will be true. But in C part, if you misplace this false and true, then your 4.75 marks is going to be lost. So be careful with this true or false. Now this is also a very easy question. You can do it within a minute. Product of 2 by 2 real rank 2 matrices is rank 2. And if we change it to be 3 by 3 rank 2 matrices, it is at most 2. And if you change it to be 3 by 3 rank 2 matrices, then it is at least 2. And product of 2 by 2 real rank 1 matrix is of rank 0, not is of, can be of rank 0. Hope you are done, right?
Yes, ma'am.
Option C.
Option C.
Option A and C.
A and C. Why A and C? It's only option C. I will explain. So product of 2 real rank 2 by 2 is of rank 2, because since this is 2 by 2 and has rank 2 implies what? A is invertible, right? Again, if you consider rank 2B, then also it says B is invertible. Now, what about AB product? If A and B are invertible, then it is nothing but B inverse A inverse, right? So AB is also invertible. Means what? Rank of AB is 2. So the statement of option A is true, but we are asked for false. But so we don't want that option. Then another question is, if you take 3 by 3 and you have a rank 2, then the product is having at most rank 2. How can we say that it is true? Rank of A is 2. Rank of B is 2.
Rank of AB will be less than or equal to minimum of rank of A and rank of B.
Okay, you can either remember this formula, rank of AB will be less. This is some Sylvester's law or something. I usually don't go for the formulas, so maybe I will explain you in the linear algebra technique. So A is a map from R3 to R3. Similarly, B is also a map from R3 to R3. Now, AB is also a map from R3 to R3. Now, from this equation, you can easily see if something is in the
Maybe it's
range.
not onto.
Huh?
Maybe
AB
it's not onto.
that is okay. So, AB is having a range contained in range of it, right? Because if Y belongs to range of AB, then what does it say? There exists X such that ABX equal to Y. That is nothing. You choose Z to be BX, then there exists Z such that AZ is Y, which means what? Y is in range of it. So this relation is true, right? Oh, sorry, what is this AB subset? Range of, okay. A range of AB is subset of range of A, which implies a rank of AB should be less than or equal to rank of A, right? Because it's dimension. Now, we know rank of A is nothing but 2. That is what it is saying. Rank of AB is at sorry, it's some disturbance. So, product of 2 3 by 3 real matrices at most rank 2 is actually true, so we don't want that. Of course, then this is actually false, right? We know that it's the opposite. So, can you please mute it? Okay. Then the fourth option is saying product of 2 by 2 real rank 1 matrix is of rank can be 0. So what is this? You may take product of 2 real things. So I am now choosing this. This as one matrix. And maybe I will write in the order. And this is another matrix. Now both of these are of rank 1, clearly. Now if you multiply, this is nothing but 0, 0. Then this is nothing but again 0, 0. That is, product of 2 rank 1 matrices can be of rank 0. So this statement is also true. Now shall I move to next?
Ma'am, can you explain the first option once more?
Okay, so first option, what does it say? It is a 2 by 2 rank 2 matrix, right? So it is a full rank. Means a rank of A is 2, rank of B is 2. Whenever we have a full rank matrix, we know it is invertible. Right?
Yeah, ma'am.
So A is invertible, B is invertible. Now their product is also invertible. So for invertibility, we need full rank. Means AB has rank 2.
Okay, ma'am. Thank you.
Okay. Now comes this. Again, an analysis convergence. So see how many questions they're asking from the series part. If you know the test of some series, then you are done with 3 marks. These are section B questions. Okay, this is a section C question, but the previous thing that we said deal with was from section B. So just see, AN is given to be this. Which of the following is true about the series summation AN? Whether it is divergent, whether it is convergent, conditionally convergent, and absolutely convergent. If you don't know meaning of conditional or absolute, then you can ask me. Otherwise, you may try. For this, you should not take more than a minute.
Ma'am, option B and C.
Yes. So since this is easy, I will start. Okay. Now, an can be seen like this, minus 1 power n plus 1. You multiply and divide by its sort of conjugate that we say. It's not a conjugate, but still. Then what does it looks like? Minus 1 power n plus 1 by, this is nothing but a square minus b square, which is n plus 1 minus n, which is 1. And the remaining is the denominator. So see, again, it's an alternating series. So alternating series test should come into your mind. This is nothing but this plus this. Now we know this converges, decreases to 0, right? Because n diverges to infinity. Then also this is decreasing is very clear, like this is n plus 1 plus n, and this is less than or equal to square root of n plus square root of n minus 1. So I am comparing bn and bn minus 1. I want to compare bn and bn and n minus 1 this way. So this is actually the other way. But my bn and bn minus 1 is 1 by, so the inequality reverses. So this is decreasing and it decreases to 0. So by alternating convergence test, series test, it is convergent. Now what is the meaning of conditionally converging? What is the meaning? So in an alternating series, say minus 1 power n bn, you can see two separate series. What are they? Two positive series. What are they? Say, if this is starting with minus 1 power n, then consider its positive as well as its negative. So negative will be like this. Right? So if you consider E1, this is a positive. So this should diverge to infinity. And if you consider the negative terms, then this to diverge to minus infinity. If this happens separately, then we say that the series is conditionally convergent. Now, from our given thing, it is nothing but one part is so the positive things comes when n is odd. So when n is odd, our bn looks like, anyway our bn looks like this only. This. Now this will be actually greater than or equal to 1 by, you can replace this square root of n plus 1 by again root n. Right? This is greater than or equal to 2 root n. And this converges to infinity. Sorry, diverges to infinity. And if you look into the E1, then it is negative, right? Instead of writing again bn, I will write, maybe the given thing is, this is minus 1 by n plus 1 plus root n. Now this can be made bounded above by minus 1 by 2 root n plus 1. Now this we know diverges to minus infinity, as its positive term is not converging. So they are diverging to corresponding plus and minus infinities, means they are conditionally convergent. Okay. Now once they are conditionally convergent, they cannot be absolutely convergent. So this is false, and once it is divergent, it cannot be. Sorry, once it is convergent, it cannot be divergent. So now we are done. Now next is, this is a kind of real analysis that they have connected with just graph, drawing of graph of a function. So the real part is actually here. What is the notion of infimum of a set? So given a set which is nothing but all those x in R, where x square minus 9x plus 18 is less than or equal to 0, and x square minus 7x plus 12 is less than or equal to 0. Now what will be infimum of this set? You may try for 2 minutes because it takes time to draw the graph and see, or some other ideas if you have, you can share. One thing for time consuming, I will tell you, like, observe that this is a quadratic, right? So it is a parabola actually, some shifted parabola. Think in that way. So complete the square of these equations and try to get a picture of these two parabolas. Try to figure out the region less than or equal to 0. Then look into only the portion of the intersection with x-axis. This is nothing but you intersect that picture with x-axis. Then you find the infimum.
Ma'am, answer is 3 by wavy curve.
By what?
Wavy curve.
Yeah.
C.
Yes. So the thing is, first equation is nothing but x minus 9 by 2 square minus I plus equal to 9 by 4. Right? Square. Yes. And the second equation is nothing but x minus 7 by 2 square, and then 49, 48, 1 by 4. Am I right? Now you may plot the things. The thing is 1, 2, 3, and 4. So for we may need of more than. Okay. 1, 2, 3, 4, 5, and 6. So 9 by 2 means 4.5. 1, 2, 3, 4, 4.5. At 4.5, the value is 2.25. So 1, 2, somewhere here. So the parabola have origin here, and it is upward, x square minus something. So just you have to see when it meets the x-axis. So let's equate. Then it says x equal to plus or minus 3 by 2 and then plus 9 by 2. This is having values 12 by 2, 6 and 6 by 2, 3. Now again equate this. This is having, okay, this is 6 and 3. So 6 and 3. So this parabola is something like this. Since we need only about x-axis, I am not drawing after that. This is actually x equal to plus or minus 1 by 2 plus 7 by 2, which is 4 and then 3. So the common point is 3. From there itself you can guess, but let's try to figure it out. So where it 7 by 2 means 3.5. So somewhere here is 3.5. And then value is 1/4, somewhere here. So the parabola should touch the x-axis at 4 and 3. So the parabola should be something like this. Now you are asked to find the intersection with x-axis, means only this. So actually your set U was nothing but the interval 3, 4. Okay. And then they are asking the infimum, which is nothing but 3. Is it okay?
Ma'am, shall we find the infimum by using the roots of the equation?
Using roots of the equation. Roots will land up in x, that is okay. But then the infimum may not occur at a root. It may occur still before that. Like if I ask instead of this, if I ask greater than or equal to, then actually you see the region is nothing but this, right? Then the point is there is no infimum. If I turn out to be like this, then one region is this and another region is this. It should include 0, right? So then there is no point of infimum. So better if instead of using some ideas or techniques or like that, you just see what is happening over there and then do the things. Okay?
Okay, ma'am. Okay.
Now let S be an infinite set. Then which of the following is true? See, this is another question that deals with countability, uncountability in another 2023 paper. This is a straightforward. You may answer now itself.
Ma'am, answer C.
Of course. So this needs no explanation, right? You already know for infinite set may be irrational, which doesn't match with this. Infinite set may be Q, which doesn't match with this. And of course, for any S, any finite power of S will have a same cardinality. And for S, of course, this is the contrast there, that they cannot match. Okay. Now, this is a question that I included because this kind of questions they are asking in very different manners, in very different question papers. Like, I guess they asked in 2018, 2019, everything. So still they are asking in 2023. That's why I included it, because this is a very easy question. This is not based on real or linear, but you can score 3 marks if you know the technique. Even if you are not a person reading numerical analysis and preparing numerical analysis and attending the exam, you just remember this thing, Descartes' rule. Spellings may be different, but I will say what it says. So given an fx, it says number of... Hello?
It is René's Descartes rule.
Okay. So given this fx, number of positive roots. Positive means it's understood it is a real. So positive roots is at most number of sign changes. And number of negative real roots. is at most number of sign changes of, instead of f of x, consider f of minus x. Now you see the beauty. You can bound the positive real roots by a number. You can bound the negative real roots by a number, and you can easily check whether 0 is a root or not. So you always have a bound on number of real roots. And another thing that we know is that always the complex roots occur in pair. Right? So with these three ideas, you can straightforward solve this problem. But if you are not looking into this rule, or if you are unaware about the numerical analysis, you may not do this and you may lose 3 marks because of the easiest problem. So for that reason, I included this. Now you may tell what is the answer. This is sign changes of f of x.
Miss 1.
Yes. So you may see, what is the meaning of sign changes from cube to the next number? If you go, this is plus, this is plus. So no sign change. From here to here, if you go, this is plus and this is minus. So there is a sign change. So number of real roots will be less than, or positive roots will be less than or equal to 1. Now if you write f of minus x, it will be minus x cube minus 3x minus 2022. Now this may repeat as 2024. Now the thing is, there is no sign change from here to here and from here to here. So no negative root, right? So at most one positive root, no negative root. And what is f of 0? This is minus 2023, which is non-zero. So 0 is also not a root. Now we know complex roots occur in pair. Because of this reason, since we have a cubic polynomial and it have 3 roots, at least one should be real. And here we know at most one is real. Means what? Exactly one is real. Exactly one real root. Okay, shall I move on to next?
Ma'am, this rule will work for only polynomial case, polynomial function.
No, polynomial.
Only polynomial.
Yes, yes.
Okay.
Because there is sign change. Means what is the change? It says between the consecutive x power n's, you have a change or not. And if I give you some sin x, this is a function. But there is no notion of sign change, right?
Yes, that purpose I answered. Okay, thank you.
Yeah. Now, this is an interesting linear algebra question. This kind of questions you can see almost in all papers. They will give you a subspace, another subspace, find its smallest subspace containing these, and then they might ask with some dimension. So read this. V is a set of all polynomials of degree at most 10 in a single variable x over R. And W is the subspace of V consisting of all polynomials of degree at most 5. Again, W2 is the subspace of V with sum of the coefficients to be 0. Now, W is the smallest subspace containing W1 and W2. Then which of the following is true? For this, you may take 2 minutes. Then let's discuss. Once you are done, you can tell me.
B option.
Yes, B is true. Then only B.
So just let me check again.
Someone said something else also.
Whether option C is true.
D. Whether C is true or not. No, C is not. So we'll wait for a minute because others might be still doing. Let us give them time. Okay. Let's start. So what is it given? I will have some notations. So V is nothing but polynomials of degree at most 10 over R in terms of only X. Okay. Now, what is the dimension of V then? It will be spanned by 1x square up to x power 10. So we have 11 as its dimension. Do you agree with this?
Yes, ma'am.
Okay. Now, what is W1? It's kind of this, but up to 5 we are taking, right? Then again, we know dimension W1 is nothing but 6. Now, what is W2 doing? W2 is doing nothing. You can just take all P of X, A0 plus A1X plus etc. plus A10 x power 10 such that A0 plus A1 plus etc. plus A10 should be 0. What does this actually mean? You have the freedom to choose A0, A1, etc. Up to A9, you have the freedom to choose. Right? But A10 comes automatically with this. Means dimension W2 is actually 10. That is, you can see the basis to be, if you choose 1, then automatically x power 10 minus x power 10 comes. If you choose x, automatically this comes. Up to, if you choose x power 9, automatically this comes. You can just verify this is a basis for W2 and dimension is 10. This is how you easily see the basis of a subspace. Now, what is a given? W is the smallest subspace containing W1 and W2, which is by notation this. Now you can see what is this W1 actually containing? It will contain all this 1x, x squared, etc. x power 5. Now, what is this W2 containing? Everything of this form, right? 1 minus x power 10, x minus x power 10, etc. x power 9 minus x power 10. Now my question is whether this is full of V or not. This is my question. Now, you can take elements which is basis of V, say 1. 1 belongs to V. 1 is nothing but 1 plus 0, where 1 is in W and 0 is in W2. This you can do up to what? X power 5. Say x power 5 will be. Then x power 5 is nothing but x power 5 plus 0. Now, if you take x power 6 in V, then x power 6 is nothing but x power 6. This is actually an element of W1. So, x power 5. This is actually an element of W1. And to make it x power 6, I just add x power 6 minus x power 5. This is actually an element of W2. Why? You see, this polynomial is satisfying the condition that if you add the coefficients, it is 0. Right? This idea you can continue till x power 10. So for any x power 10, you can just make it again x power 5 plus x power 10 minus x power 5. This belongs to W1 and this belongs to W2. This idea says that every element of V is contained in W1 plus W2. Of course, W1 plus W2 is contained in V. Means what? V is actually W. Is this clear?
Ma'am, can you explain how that basis is taken 1 minus x power 10, x minus x power 10?
Oh. So, very natural basis of a polynomial is 1 x square. Let me finish it with 3, okay? Let this be something else. So, if this is vector space, then what does the meaning of W2 says? Consider all polynomial such that coefficient sum up to 0. Right? So, how does a general polynomial looks like? You can choose a0 plus a1x plus a2x square plus a3x cube. Right? Now, what is the condition that it should be in W2 means a0 plus a1 plus a2 plus a3 should be 0. In other words, a3 should be a0 plus a1 plus a2 and minus. Do you agree?
Yes.
Now, how does our polynomial looks like? This looks like a0 plus a1x plus a2x square plus, instead of plus, minus a0 plus a1 plus a2 x cube. Okay? Is this okay?
Yes, ma'am.
This is the elements inside W. Now you are asking, what is it looking like? Like corresponding to 1, you can choose any element and span it, right? Now corresponding to the basis x, you can choose any element and then span it. Corresponding to the basis again x square, you can choose any element and span it. But corresponding to x3, from the chosen, you are having something. Right? So, how many independent ways you can choose? There are independent way of choosing A0, A1, and A2. Right?
Yes, ma'am.
But the coefficient of x3 comes automatically. So I am choosing like this. Consider 1, which I always choose. Now, to make it to be an element, what should be always there? I am choosing A0 to be. So this is equivalent to choosing A0, A1, A2, and automatically A3. This is the subspace we are looking into. Now, how can I choose? I will choose 1, 0, 0. Then automatically what is this? -1. Another way is I can choose 0, 1, 0. Then automatically this is -1. Another independent set that I can choose is 0, 0, 1. Then automatically this is -1. Which in terms, I write it in terms of polynomial is nothing but 1 minus x cube, 1 minus, x minus x cube, and x square minus x cube. Now you got how to create the basis?
Yes, ma'am. Clear.
Okay. So this is a standard question that they always ask you. Give some function, whether it is uniformly continuous on some interval. This you can check within a minute. It will be very easy if you know the graphs of some standard functions.
D.
D or B, whichever you told.
Ma'am, answer for last question.
Okay. You want to go to last question?
Yes, ma'am.
Oh, I didn't complete it.
Okay.
Sorry. Sorry. I thought it is finished.
Okay, madam.
Okay, so we were actually doing with this. We are done with this now. Is that okay?
Yes, ma'am.
Till that we have done. Okay. Now consider this A. What does it say? Dimension is less than or equal to 10. But dimension W means dimension V. We know dimension V is 11. So that is false. Now, what does this say? W1 is contained in W2. So W1 is what? All polynomials of less than or equal to 5, right? So if I take 1 is in W1. But 1 belongs to W2 is true? No, because if you add the coefficient, it is just 1. It is not 0. So 1 does not belongs to W2. So this is false. Now comes to the intersection part. Okay. Nice that you pointed out. Otherwise, I would have gone with the other part. So this is the formula. Tell.
If W2 is contained in W1, if that option was there, whether it will be true?
No, still not true. Still not true. You can see this is in W2, but this is not of polynomial at most 5 degree, right? Then it is not in W1.
Thank you.
Okay. So dimension of W1 plus W2 is nothing but, as everyone knows, this is the formula. Right? Now we saw this is nothing but V. Now, what is the dimension of V? 11. What was the dimension of W? 6. What is the dimension of W2? You have freedom to choose 0 to 9, but not the 10th one. So, dimension is 10. And this is what you want to know. Let me call it as X. Then X is nothing but 16 minus 11, 5. So it is actually equal to 5. And then they are saying at most 5. So that is also true. Is it clear now?
Yes, ma'am.
Okay, then let's go to the next. Now you can do this. This we should do within a second or so. Like we have to have a very good idea about the graphs. So which theorem comes to your mind about checking uniform continuity on AB? F on AB is uniformly continuous. If and only if limit
exists.
Yes, limit A fx, and here I am writing both. Okay, exists and is continuous on AB. Right. So, what is sine 1 by x? Do you know the graph of sine 1 by x? It comes like this, and as soon as it reaches 0, it starts oscillating like this. So near 0, as you can also see, as x goes to 0, 1 by x goes to infinity, right? And if some x goes to infinity, sin x, what is this? It oscillates between -1 and 1, right? The drawing may be wrong, like it should go till this, etc. But the thing is, it oscillates between -1 and 1, rapidly close to 0. So the thing is, limit does not exist. So this is not uniformly continuous. Now, if you know e power -1 by x squared, instead of knowing the graph, let's put the value. X tends to infinity, -1 by x squared tends to -infinity, right? But then e power -infinity is what? Should not write like this, but still, e power -infinity is what? 0. See, graph is like this, e power x. So this is actually uniformly continuous. No need to check with 1 because there is no problem in 1. The only problem was with 0. So if we apply the limit, then the limit exists and is continuous. So now you have to know the graph of, okay, instead of knowing graph, this is fine. What is this? 1 by x goes to infinity and sine 1 by x goes to oscillate between 1 and -1. Then it oscillates between +infinity and -infinity. That is, the graph will go like this, but we can't draw that it is oscillating between. So the thing is, it will rapidly increase when it comes to 0. So again, this is not true. This is not uniformly continuous. Now you closely see the graph x sine 1 by x. X sine 1 by x. To have a better idea, let's look into what is it. Sine of something is always less than or equal to 1, so it is less than or equal to mod x. So I will draw mod x. What is mod x? This is mod x. Now what does it say actually? Minus mod x less than or equal to x sine 1 by x less than or equal to mod x. So the graph is actually lying between mod x and minus mod x. This is actually mod x. This is actually minus mod x. And the oscillativeness of sine when it comes close to 0 is like this. It oscillates like this. Still it oscillates very rapidly, but bounded. That is the point. So this boundedness makes it continuous at 0. You see the point? So x sin 1 by x is continuous at 0. For your extra information, I will show you how x square sin 1 by x behave, and you have to compare these three: x sin 1 by x, x square sin 1 by x, and sin 1 by x. There is a good thing to compare here. The good thing is nothing. At 0, sin 1 by x was not continuous. At 0, x sin 1 by x is continuous, but not differentiable, because there is a sharp end over here that comes with the mod x, right? So it is not differentiable. But if you see x square sin 1 by x, the idea how to draw x square sin 1 by x is also like this. X square sin 1 by x, mod will be less than or equal to mod x square, which is nothing but x square, right? So minus x square less than or equal to x square sin 1 by x less than or equal to x square. That is, the graph lies, you have to draw, this is x square, this is minus x square. Now sin 1 by x oscillate between this. So how much ever they oscillate, they're still bounded by this x square and minus x square. So it is continuous. And if you closely see, at 0, there is no point convergence. Like, there is nothing like mod x kind of. It is so smooth. It is x square. It is actually approximated to x square at 0. So this is differentiable. You may check with the definition of continuity, differentiability, etc. But it is too hard to check at exam time, right? So you just know about these three functions, that they always forms counterexamples, or they always help us in negating the options. That's why I'm saying this is differentiable. This is continuous, not differentiable. This is not continuous. Okay. Shall I move on to next? So the answer is e power this thing and x sin 1 by x.
Ma'am, could you please repeat the third option? 1 by x sin 1 by x.
What is the limit of 1 by x sin 1 by x? Limit 1 by x sin 1 by x, and x goes to 0. This actually oscillate, right? And this goes to infinity. So the limit is not finite. That's it. Okay.
Fine, ma'am. Thank you.
Now this is an interesting question. You will get to know everything about minimal polynomial, characteristic polynomial, diagonalization, everything. So let's do this. T is a linear map from R3 to R3. Satisfy this polynomial equation. Which of the following is true? There is a basis with respect to which T is symmetric. Again, there is a basis with respect to which T is upper triangular. There exists non-zero vector V such that TV equal to V. Means what? 1 is an eigenvalue. Now their x is linearly independent. So there is linearly over here, which is understood, but still. Linearly independent vectors v1, v2 such that t v1 equal to v1 and t v2 equal to v2, which means what? The eigenvalue 1 has at least 2 as geometric multiplicity. So you may think upon it for 2 minutes and then tell. Once you are done, you can tell me. Okay, shall we do? Because I have more questions. Huh?
Is it BCD, ma'am?
No.
I think it is A, B, and
Option
C.
A, B.
Still no.
D, ma'am.
No.
B and C. I'm D.
Option
No.
A and B.
Yes.
Ma'am, A, B, C, D.
Oh, no. Option A and B. That's why I was interested in this question. Actually, I will tell you a common mistake that everyone will make. What is this? Given this T will satisfy this, right? Now you can easily solve this polynomial and you can see the roots are nothing but 1, 1 plus root 3, 1 minus root 3. I'm not wasting time for it. You can do it. As soon as you see this, you lands up in a conclusion that 1 is an eigenvalue. And you have 3 distinct eigenvalues. So it is diagonalizable. And so and so. Whatever you wish, you will assume this. Have at least one assumed this? I'm sure, yes. That's why you were telling C is true. Right. But now I am asking you, it is not given that this is the characteristic polynomial of T. It is only given that T satisfies this polynomial. That is,
This is annihilating.
this is an annihilating polynomial. That's it. Right? Now you just consider the operator this. 1 plus root 3 identity. What is the characteristic polynomial of this? Minimal polynomial is nothing but x minus this. This is the minimal polynomial. And what is the characteristic polynomial? This is nothing but its cube. Right? Now I am asking whether T satisfies this equation. T should satisfy. Why? Because this is actually root of the given polynomial, right? So T actually satisfies this. But does T have 1 as an eigenvalue? No. T is nothing but 1 plus root 3. 1 plus root 3 and 1 plus root 3. And zeros otherwise. Does T have 1 as an eigenvalue? No, right? So those who told me C is also true might have thought in this way that the roots are this, so the eigenvalues are this. This should not be done. You agree with me?
Yes, ma'am.
Okay, so the way how you should think is the following. Annihilating polynomial is given something. What is it? This is the annihilating polynomial. Now you know minimal polynomial will always divide your annihilating polynomial, right? So minimal polynomial has the following choices. It can be x minus 1. It can be x minus 1 plus root 3. It can be x minus 1 minus root 3. It can be x minus 1 into x minus 1 plus root 3. X minus 1 into x minus 1 minus root 3. X minus 1 plus root 3 into x minus 1 minus root 3. And still it can be p of x. So these are the possibilities of minimal polynomial. Now this will help you to rule out or think about the choices. Suppose I take this as the minimal polynomial or anything as the minimal polynomial. What does you observe? It have distinct root and it splits into linear factors, right? Mx splits into distinct linear factors. As soon as you know this, we know corresponding operator T is diagonalizable. Do you agree with this?
Yes.
Then what does it say? The Rx is the basis. With respect to which you can view T as diagonal elements alpha 1, alpha 2, alpha 3. As soon as you have this, when will this be symmetric? For this thing to be symmetric, you have to just note their values. These things are symmetric. Means what? Their bar is 1. Means they are real, right? Now we know the roots are nothing but, if at all it has root, then the roots are nothing but 1 or 1 plus root 3 or 1 minus root 3, which all are real. So there exists a basis with respect to which T is symmetric. You got this?
Ma'am, can you explain once more?
Yes, of course. So we know an annihilating polynomial, right? What do we know? Any annihilating polynomial will be divided by the minimal polynomial. Right? So this, you have found this to be this. By finding its root, you have found this. This is nothing but this. Now, if at all mx is the minimal polynomial and it should divide this, what are the possibilities? Mx should be either this or this or this, and all these are the possibilities. Till this you are clear?
Yes, miss.
Now, this is a result, you can say. If minimal polynomial splits into linear factors which are distinct, means, I mean, this kind of things cannot occur. This is not distinct, right? Even though it's split into linear factors, this is not distinct. Means you can write this as x minus 1, x minus 1 and x minus 2. So it splits into linear but not distinct, right? So if mx splits into distinct linear factors, then the corresponding t is diagonalizable. This is what the result says. So as far as we know all the possibilities of mx, we can check. In all cases, we know it is splitting into distinct linear factors. So it always says that t is diagonalizable. Now, what is the meaning of diagonalizable? There exists a basis with respect to which the t looks like diagonal matrix, right? Are you clear?
Yes, ma'am. And suppose if they are given the polynomial this as characteristic polynomial,
then you can directly say this is diagonalizable.
Okay, we can conclude the minimal polynomial is also p of x. Am I right?
Exactly, exactly. Why? Because the roots of minimal polynomial and roots of characteristic polynomial must be the same, and minimal polynomial cannot have more than characteristic polynomial's power.
Okay.
So the
Thank
minimal polynomial should be linear and this distinct, exactly p of x.
Okay.
Okay. So from here we know t is actually this diagonal up to some basis. And when is a diagonal matrix symmetric? It is if and only if the diagonal entries are real, right? And what is actually the diagonal entries? It is the eigenvalues of t. What is the possible eigenvalues of t? 1, 1 plus root 3 and 1 minus root 3. They are actually real. So it is actually a symmetric matrix. Did you get?
Ma'am, diagonal matrix is always symmetric, right?
In terms of real symmetric, it is always. But if you see I10, what is its conjugate? Means A star. This is minus I10. They are not same, right? So by symmetricity, I have included in my mind complex also. Got the point?
Yes, ma'am.
So since everything happens over R here, you can always assume that this is actually symmetric because the eigenvalues lands up in R, everything happens. So there exists a basis with respect to which T is symmetric. Now, what is the meaning of upper triangle? Diagonal is always an upper triangular matrix, right? Upper triangular just means the lower part is 0. Upper and diagonal can be anything. So with respect to the same basis, we know that it is upper triangular too. Now we saw an example where TV is not V. Then how can you choose two independent vectors? Even one is not there. Have you got the point?
Yes, ma'am.
Oh.
Yes, ma'am.
Yes, ma'am.
Okay, then good. Sir, I would like to continue with one more question, shall I?
Yeah, sure.
Okay. So this is actually a real analysis question you can do within arithmetic. Sorry, what is it? Archimedean property. That I am not doing now. Huh?
Excuse me, ma'am.
Tell me.
Last question answer.
Answer is A and B.
A and
A
B.
and B. Yes.
Okay, thank you, madam. Okay, thank you.
So this you can do as a homework, which is very easy. You just want to apply Archimedean property. That's it. I would like to do a similar linear algebra problem that we have done now, so that I am sure that you are understanding the things. You have a n by n real symmetric matrix. Which of the following is necessarily true? Necessarily true means what? For every A with symmetricity, this should be true. This is what necessary means. So please go through Just tell me within 1 minute.
Ma'am, here A is a real symmetric matrix?
Yes.
Okay. Then option A, B, C, D.
Good. Why so? You may explain. Come on.
Symmetric matrix by spectrum theorem. It is diagonalizable. And its eigenvalue are real. And this polynomial a ki power k is equal to I, which is annulating polynomial. We get a 2 result. If it is even, we get a is equal to minus plus minus I. And if a is odd, we get a is equal to I.
But let me ask one more. What if it is 4? Then how you get only 1 and minus 1?
Okay. If
Here the A is a matrix of
A is an n matrix. You can have 4 order also.
Yes, ma'am.
But the thing lies in spectrum that you told me just now. Okay, that part I will explain you. So as she was telling, any symmetric matrix is diagonalizable and spectrum will be contained in R. If you know the proof, then it's okay. If you don't know, you can see first spectrum is contained in R. Suppose lambda belongs to spectrum, then you can say that AV equal to lambda V for some V non-zero. Now you consider lambda norm V square. What is this? Lambda inner product VV. Now what is this? Lambda can be taken here. Now lambda V is nothing but AV. By the definition of adjoint, it is A star V. Since A is symmetric, it is again AV. Again, AV is nothing but lambda V. But lambda comes in the second, so it comes out with a bar VV, which is nothing but lambda bar norm V square. Means what? Norm V square is a non-zero entry, and you have this. So lambda is nothing but lambda bar. Means what? Lambda is real. This much are you clear?
Yes, ma'am.
Now, what is the meaning of a matrix not diagonalizable? Suppose A is not diagonalizable, then it just means it has a Jordan block corresponding to some lambda like this, which also means that it has a eigenvector. So it has V such that A minus lambda is non-zero, but it is a generalized eigenvector, means this is 0. It need not happen with 2. It may happen with higher order. For easy computation, I am taking this. Okay. So this is not like this. This is like this. Okay. Now, if you see, this is actually 0, right? So this is true. This is always 0, as this is 0. Now, this is nothing but A minus lambda B, and 1 I am applying over star here. Now, this is nothing but A minus lambda V, and this is A star minus lambda bar. Now, given A is symmetric, so A star is A, Given lambda is an eigenvalue, so we know that lambda is lambda bar. So this is still what? A minus lambda b, which is nothing but norm of A minus lambda b. But see, norm of A minus lambda b is 0 means what? A minus lambda b is 0. So there cannot exist a generalized eigenvector for any eigenvalue. That is, every symmetric matrix is diagonalizable. You got the proof? Got it?
Ma'am, please explain it once more briefly.
Okay. So if it is not diagonalizable, then by Jordan form, it says that you have some Jordan block like this. That is, you have a vector v such that AV is non-zero. So if you apply v over here, then it says that AV is non-zero. But if you apply v over here, then it's 2 times, that is square v is 0. If you see what is j square, then it is nothing but 0, 0, 1 or something. Something. Don't go to that. It just says that there exists a vector in generalized eigenspace. Means for v it not be 0, but for some higher power it may be 0. Got it?
Okay.
Now since this is 0, you just substitute 0 over here. That inner product is 0.
Yes, ma'am.
Now there are 2 things, A minus lambda, A minus lambda. Take one A minus lambda and act as an adjoint. Okay.
Okay.
Now, what is A minus lambda star? It is A star minus lambda bar. But A being symmetric, A star is A. And lambda star means lambda bar. But lambda bar is lambda since lambda is real.
Yes, ma'am.
So this is nothing but A minus lambda v. Now consider this is a vector, say W. Then it is saying inner product WW. That is norm of W square. Okay. We got norm of something is 0, means that vector itself should be 0. But we started with something non-zero, so that gives a contradiction.
Okay.
So means symmetric matrices are diagonalizable. So then A is diagonalizable. Now comes annihilating polynomial is this. So xk minus 1. This is the annihilating polynomial, right? Since A is diagonalizable, the minimal polynomial should be what? Having eigenvalues, right? So it can be this, it can be this, or it can be this. If you have more roots like this, this, and some omega, then it says omega is an eigenvalue for A, right? But we know only real roots are eigenvalues for a symmetric matrix. So the only possible roots from this is actually what? The solution is actually what? Kth root of unity, right? Kth root of unity. When will kth root of unity land inside R? Only when it is plus or minus 1. So the minimal polynomial is actually composition of minus 1 and plus 1. Nothing like omega other than minus 1 and plus 1 can come. Right? And then you can easily see what is this? This is nothing but A square equal to identity, right? Whether this is the case, then it says A equal to identity. Then of course A square is also identity. If this is the case, then it says A equal to minus identity. Then A square is identity. If this is the case, then this is nothing but x square minus 1, which again says A square is identity. Got the point?
Yes, ma'am.
Now, what about C? It is saying its power is 0. Means what? A is a nilpotent operator, right? And we know only nilpotent operator that is diagonalizable is 0. Nilpotent plus diagonalizable implies 0. So A is actually 0. Then A square is also 0. That square they're just giving to confuse you. Now all eigenvalues, this also is so. So are you done with this 4? Is everything okay?
Yes, ma'am.
Okay, then thank you.
Okay, thank you. Thank you, Sneha.
Thank you, sir.
Dear participants, now let's move to the feedback session. Here you can share your feedback, and also if you have any query, you can ask. Feel free to ask your queries.
Yeah, of course.
Hi ma'am, my name is Saria and I'm an MSc student from 𝐰𝐢𝐭𝐡. And this section was so nice, ma'am. First of all, I want to thank you for you. And your way of explanation is so nice, and the section is really helpful for me. Not only for doing problem, I can able to approach the questions the way of a different way that you are explaining. And thank you very much, ma'am.
Thank you.
So many people are responding in chat box.
Okay.
Thanks. Dear participants, feel free to say some words. It will be really an inspiration for us.
Hello, ma'am.
Yeah.
Hi.
I'm Hiba.
Huh.
The way you have explained each and every question was so nice, and the way you have explained each point is too good. Thank you, ma'am, for the session. We are expecting more sessions from you. Thank you.
Thank you.
Thank you, Hiba.
Hello, ma'am. I'm Preeti.
Hi.
Ma'am, your way of explanation is very good, and the way you approach the problems in different ways was really helpful because I am preparing for CSI, and thank you for the session.
Okay,
Hello.
thank you.
Yeah. Hello, Preeti. Could you introduce yourself?
I'm Preeti Mato. I am currently preparing for CSI NET examination.
Okay.
And
you are from which place?
I'm from Gandhinagar, Gujarat.
Where are you studying?
I've studied in Gujarat University.
Yeah.
It is in Ahmedabad.
Okay. Okay, all the best for your preparations.
Thank you, sir. Thank you, ma'am, for the session. It was really helpful.
Thank you, Vinod.
Thank you. Yeah, others.
And if you have to ask any doubt also, you can ask.
Yeah.
Ma'am, in last question, I was not much clear about how it has been used, the idea. Maybe I'm unaware about the, the formula, the technique. So I think that is the problem. So I want more explanation for that question.
Preeti, we will share the recording and also the notes through our group. Okay.
Yes, sir. That will be helpful.
And still, if you have further doubts in that, you can message. Okay, you can message either in group or you can message to me. I will transfer that message to Sneha. Okay.
Yeah.
Okay, sir. Yeah, thank you.
Okay. Okay, others? If any of you would like to ask any questions, you can ask about ISI also. Sneha is doing PhD there now and a senior research fellow.
How to prepare the research proposal for studying PhD in ISS?
It was not clear. Can you ask again?
How to prepare for the research proposal while applying for PhD in ISSR?
PhD in which institute?
The institute you are studying right now.
ISA don't ask for research proposal.
Okay. So what is the procedure?
Like they have a common entrance exam. So it is already completed.
Okay.
So maybe you can apply next year also. So they will take via that exam. And after that, they will have an interview. And the exam will be common for 4 centers: Delhi, Kolkata, Bangalore, and Hyderabad. So I guess only three institute have mathematics as a main part. So they will be taking, and it is based on their choice. They need not take each and every year. Each and every institute may not take, right? Sometime Bangalore may take, sometime Bangalore may not take. It depends on the vacancies also. But around 5 to 4 students will be admitted once in a year to Bangalore. I said.
Okay. And any
It's after this exam and interview.
exam and interview. Any particular questions for interview? It is the pattern similar as interview questions asked.
I didn't get you.
Actually, the questions asked in the interview are, I can believe that are similar to other interview questions of PhD.
That may depend upon the interviewer. Like basically, you have to give a writing exam, which is not MCQ. That's explanatory part will be there. None of the MCQs will be there. So they may ask based on that, and they may ask your preferences, and then they will ask the interview.
Okay, ma'am, what is your research area?
I am doing an operator theory.
Okay, thank you, Preeti. Yeah, if any others, if any of you have any questions, please ask it now. Otherwise, we will wind up the session here.
Hello, ma'am. I'm Divya from NIT Trichy. Ma'am, first of all, I thank you so much for the awesome session. And actually, today randomly I entered into this meeting, but it was really very nice, ma'am. The way of explanation is amazing. Like everything you have seen through pictures.
Yeah, that is the best way to do mathematics as far as I am concerned.
Yeah, ma'am, that is nice. Ma'am, what is the procedure for applying a PDF position at ISI? Do we need to approach a particular faculty earlier, or in order
So
to
are you a PhD fellow or?
I'm a PhD student, ma'am.
Okay, so you want to apply for postdoc?
Yes, ma'am.
That I will let you know later because I have not thought about it, so I don't know the procedures. You know Sri Lakshmi there, right? PhD.
Yes.
So I will tell her, then she might tell you.
Okay, ma'am. Thank you so much.
She is my best friend, so she will tell you.
Great, thank you.
Okay, thank you, Divya. Dear participants, we are arranging these type of sessions regularly. So tomorrow morning also we have a session on probability and statistics. Okay, a faculty member from Birla Institute of Technology, Misra, will handle the tomorrow's sessions. So I welcome all of you to attend that session. It will be really helpful in your NET examination. Okay, Sneha, once again, I'm very happy to express my thanks to you for being.
Thank you so much for inviting me also, sir.
And today's session is also very nice with good interaction. So actually, it's very difficult to keep the people engaged throughout the session in an online more. Yeah, but
Yes.
in today's session, we have almost 100 participants throughout the session.
Oh,
Only
okay.
people after this, as the interactive session started. Okay, up to that time, there was a good number of people throughout the sessions. So I feel very happy, and I'm sure that you have succeeded in getting the attention of the participants throughout the program.
Okay, sir. Thank you.
Okay, thank you, Sneha, and wish you all the very best in your academic career and research.
Thank you, sir.
Okay, thank you, everyone. Let us wind up here. Bye.
Bye, sir.